Hey folks, how's it going? This is Mr. Murray coming to you with another Do Now for Course 1 Honors. Today's Do Now is for Friday, May 15th, 2020. And welcome to the end of another week here of the closure. We're already at the end of 8 long weeks. Can you believe it? All right. So to close out the week, we're going to continue on here with exponential functions. So what I want you to do is go ahead and make a table and a graph for h of x equals negative 4 times 2 to the x minus 2, and then go ahead and complete these 6 analysis items: domain, range, increasing, decreasing, horizontal asymptote, equation, and end behavior. All right, so please go ahead, pause the video, get these 6 pieces of information and the graph and table, and then when you're ready, unpause and you can see what I got. All right. So let's jump into it. Now we need to make a graph of this. So I would say personally, I want to start with plugging in 2, because 2 minus 2 is 0. 2 to the 0 is 1. 1 times negative 4 is negative 4. Then I'll just might as well start by, move to the negative, to the 3. So 3 minus 2 is 1. 2 to the 1 is 2. 2 times 4 is negative 4 is negative 8. And this actually makes sense because remember, b is more than 1. So we're getting further from 0 as x gets larger. And this tells us the fact that a is less than 0. Remember, the graph is below the asymptote. Okay, so this makes sense. All right, now at this point 4 is unlikely to fit, so I'm not going to graph 4. So I'll go back to 1. 1 minus 2 is negative 1. 2 to the negative 1 is 1/2. Negative 4 times 1/2 is negative 2. Okay, now I'll plug in 0. 0 minus 2 is negative 2. 2 to the power of negative 2 is 1 over 2 squared, which is 1 over 4. 1 over 4 times negative 4 is negative 1. Okay, so maybe you can see as we go into the left, as x is going down by 1 each time, it looks like we're cutting in half, right? 8, negative 4, negative 2, negative 1. So when I plug in negative 1, you might not be surprised to find, right, negative 1 minus 2 is negative 3. 2 to the negative 3 is 1 over 2 cubed, which is an eighth. And negative 4 times 1/8 is negative 1/2. Okay, then when I plug in 2, negative 2, I'm going to get a negative 1/4. And then when I plug in negative 3, I'm going to get negative 1/8. And then I plug in negative 4, I'm going to get negative 1/16. Okay, so basically, this is my table right here. So what can we see? Again, as x gets greater and greater and greater, right, it gets more positive, y is getting increasingly more negative, right? Negative 8, probably I'm imagining negative 16, negative 32. As x gets more negative, we can see we're getting closer and closer, but not equal to 0, right? A negative 1/4, negative 1/8, negative 1/16, negative 1/32, but still never 0 because the numerator will never be 0. So let's go ahead and graph 0, negative 1, 1, negative 2, 2, negative 4, 3, negative 8, negative 1, negative 1, negative 1/2, So make sure it's clear. -2, -1/4, -3, -1/8, and so on and so on. So you can see, again, below the asymptote of y equals 0. Okay, folks, so if we can start to look for these common kind of patterns here, you're going to find that these things are a lot easier to tackle. Okay, so let's do analysis. Domain, -infinity to infinity. Range, -infinity to 0. Remember, use a parenthesis because it never is going to reach 0. Increasing, it's increasing nowhere because from left to right, we're always going down. So it's decreasing everywhere. Horizontal asymptote, y is equal to 0. And then end behavior. So first, as x goes towards -infinity, as we go this way along the x-axis, f of x is getting closer and closer to 0. On the other hand, as x is going this way on positive x-axis, f of x is going to -infinity. Okay, so hopefully you're able to get this do now right. If so, congratulations. If not, these are things to think about. Remembering to make our table, right? I did put the arrow here, but remembering things I'm going to continue to emphasize: arrows on both ends, nice clear points. Don't get lazy with the asymptote, right? You can start to, okay, guesstimate at this point, but really go ahead and show me that you care. Show me that big time effort to put those points on the graph like I know you're capable of. All right, so best of luck. I'm looking forward to going into another great week next week. Keep up the great work. Don't forget to love math, and remember, you can do it. All right, thanks very much. I'm looking forward to seeing everyone at the hangout, and you have a wonderful day.